Next question, which is question number 56. Orbital angular momentum of electron present in 3p orbital. So which orbital you have? 3p. For 3p, n value is 3. And what about L value? Yes, you are getting it right. L value for s orbital is 0 and for p orbital it is 1. Okay. And they are asking about orbital angular momentum. So just recall the formula. Yes, the formula is L plus 1 in the root and H cross. What is this H cross? This is H by 2 pi. Okay. Now I'm just keeping the values here. The value of L is 1, 1 plus 1, H cross, that is root 2 H cross. Where this value is given? Yes, it's clearly given in the option number 3. So I'm just marking here it as my correct answer. Now, question number 57. So one by one we are taking questions and I hope you are correctly checking them one by one. Okay. Question number 57 says, if a 44 watt bulb emits monochromatic radiation of wavelength 900 nanometer, then the number of the photons emitted per second by the bulb is. It means in this question the power is given. What power is? 44 watt. And I hope you know this is 44 joule per second. What is the relation between power and energy? Power is work upon time and work is equivalent to energy. I hope you are aware. For 1 second, if the time is 1 second, because later in the question you can also find it out. If a 44 watt bulb emits monochromatic radiation of wavelength 900 nanometer, wavelength is given 900 nanometer, then the number of the photons emitted per second, it means the total time given is 1 second. So if time is 1 second, power is 44 watt, so the total energy would be simple. It is 44 by 1 because the time is 1 second. So 44 joule. Now in this question they are telling you to find out the number of photon. How to find out the number of photon? You have to find out the energy of one photon first of all. Okay, energy of one photon, how to find it out? Hc upon lambda. Yes. Okay, so if you just divide that total energy by the energy of one photon, then you will get the total number of photons. Getting my point? Number of photons will be equal to total energy upon Hc upon lambda, right? So I'm just keeping the value of Hc. H is the Planck constant, C is the speed of light, and lambda is clearly given in the question, that is 900 nanometer. Okay, and all the SI units I'm going to take. Unit conversion is very important while solving the question. Okay, so okay, H value is 6.62. I'm not taking because in the question the value is given 6.6 into 10 raised to the power minus 34. That value I'm taking into what's the speed of light? 3 into 10 raised to the power 8 meter per second. Okay, divide this entire thing by lambda. So if you are dividing by lambda, that lambda will come here and that is 900 nanometer. I'm just changing it into meter. How to change? Multiplying 10 raised to the power minus 9. Done. Values are kept and your turn is just to simplify and solve this. Okay, the simple calculation, it is 900 by 3. Easily it can be cut. 44 by 6.6. Easily it can be cut, right? And then if you solve the value, then you'll be fine. You will be getting that 2 into 10 raised to the power 20 would be your final answer. Done. Okay, so the answer for this particular question is given here in option 2, and if you have just chosen that, this is your correct answer. Okay, now question number 58. An element X has two isotopes. Okay, 54X and 56X. What this 54 and 56 is? These are the atomic masses of these two isotopes. If mass percentage of the heavier isotope is 40%, mass percentage or the abundance you can say, then average atomic mass of the element X will be. So the formula that I'm going to use for average atomic mass is its atomic mass first of all, 54 for first isotope, okay, multiply its abundance. So as per the question, the mass percentage of the heavier isotope, right? So I'm just assuming that the abundance or the mass percentage of the heavier isotope is 40%. What is the heavier isotope? That is 56x, right? And what about the lighter one? If one is 40%, then other would be 100 minus 40, 60%. So this is the abundance for X56, and for X54 the abundance is 60%. Clear? So the values I'm just going to take here, that 54 into 60 for the lighter one, and for the heavier one 56 into 40 divided by 100. So multiply. This would be 3240 plus 2240 by 100. Done. When you solve this, you will find that answer comes out to be 54.8 U. Done. So where this answer is correctly given? Yes, it is given here in option number 2. So choose it as your correct answer. Now the turn for next question. This is question number 59. It says volume of oxygen required at STP to react completely with 64 gram of methane is. So in this question you have methane. Now volume of oxygen required at STP to react completely with 64 gram of methane. It means methane you have and it's reacting with oxygen. It means simply the combustion of methane is going on. Please learn this reaction, right? CH4 plus O2 giving me combustion resulted, complete combustion resulted in the formation of carbon dioxide and water. Okay, you have to balance the reaction. This is the prerequisite while you are using stoichiometry. Balancing is mandatory. Okay, so 2O2. This is the balanced chemical equation which is going on. Volume of oxygen required at STP to completely react with 64 gram of methane. It means the amount of methane is given. 64 gram. This amount is given. Okay. While just looking at the equation, you can simply say if 1 mole of this you had, then how much oxygen is needed? 2 mole of oxygen is needed as per stoichiometry. Okay. So 1 mole if you had, then 2 mole of oxygen is required. Now just check how many moles of methane are given. So I'm just talking about the given values. 64 gram, you can change it into moles as well. Given mass by the molar mass of methane, how much it would be? 16 gram per mole, right? And very simple calculation, this would be 4 mole. Now just look at the simple expression. 1 mole of methane needs 2 mole of oxygen. So 4 mole of methane needs, simple unitary method, 8 mole of oxygen. Clear? Now 8 mole of oxygen is needed, but they are not asking about the moles. They are asking about the volume of oxygen at STP. So I hope you know that at STP the volume of a gas we can consider as, for 1 mole, 22.4 liter. Okay. So if it was 1 mole of oxygen, then its volume would be 22.4 liter. Now it's not so, it's 8 mole. So it would be 22.4 into 8, and if you just multiply this, nearly you will get the answer 179.2 liter. And yes, the correct answer is also given in the question itself in the option number 1. Clear? Okay. Take the next question, the question number 60 we have. Correct order of energy of the orbitals for filling electrons in multi-electronic system. We're talking about simply the formula using which we can find out the energy associated with the orbital. And how it proceed? It proceed with Aufbau's principle, and very specific if I'm just going to be, it is N plus L rule. Remember this N plus L rule. So to find out the energy of the orbital, you have to just add the value of N and L. These are the quantum numbers, principal quantum number and azimuthal quantum number. Getting it? So, one by one for each of these orbital you can just consider. Here the orbitals which are given 4f, 5d, 5s and 5p. Okay. And I am writing here for S, P, D and F, the value of L is 0, 1, 2 and 3. Right? For 4f, if you just check, N value is 4, F value is 3. For 5D, N value is 5, D value is 2. For 5F, it is 5 plus 0. And what about 5P? This would be 5 plus 1. Okay. 4 plus 3, 7. 5 plus 2 is also 7. 5 and 6. So, if it is 5, 6, 7, easy to identify. But what about these two values? First value for 4f, that is 7. For 5d, it is also 7. So, in that case, you would prefer that orbital which has lower n value, right? So, which orbital has the lower n value? Obviously, 4f. So, less energy would be associated with 4f. More energy is aligned with 5d. It is clear? Now, the remaining is 5s and 5p. So, we can easily align this order. How? So, this order is correctly be written as maximum for 5d, then turn comes for 4f, we have already aligned, and then turn comes for the next orbital with the less energy, which is 5p, and the least associated with 5s. So, order is 5s, then 5p, then 4f, then 5d. So, increasing order it would be. In the question, they are not giving increasing order, they are providing you the decreasing order. So, where this decreasing order is given? Yes, it is here in option 4. First 5d, 4f, 5p and 5s. Choose the correct answer. It's clearly given in option 4. Yes, and this would be your right answer.